session, we are going to understand how regression can help in a real-time scenario. So, as I already mentioned, the hospital is, giving, treating the maternity cases, and they take care of children up to the age of, let's say, 1 year or something. See here, they have some data available. According to the data, the height of the babies is written here, and the weight of the baby, maybe in kilograms, is written here. Height in terms of centimeters is available here. Height in terms of kilograms is available here. Now, what are we trying to predict? We are trying to predict whether there is a relationship between the height of the baby and the weight of the baby. What is your guess here? Do you think the height and weight will have some relationship as far as
weight increasing and height also increasing?
Very good. So the regression equation is developed. We all know the technique of developing the regression equation. It's a single factor. So simple linear regression, it is done. Now I also wanted to predict. Suppose if the height is 75 centimeter, see here 75 is not available here. Suppose if a baby is born, I don't know whether baby can born with 75 centimeter or not. I'm only for example sake I'm saying, right? So if a baby has a height of 75 centimeter, what could be its weight? See here, the regression is telling you the baby will have a weight of 8.74 kg. Maybe after birth case it is, right? While during the birth, the baby height is very less, maybe 40 centimeter or something, maybe less. But when the baby grows to 75 centimeter, you can expect the baby to have a weight of 8.74 kilogram. Will it be true? Standard error of fit is calculated using the same data. Standard error is calculated, nothing but your standard deviation. Standard error is nothing but standard deviation divided by square root of number of data. Standard deviation divided by square root of number of data is the standard error. How many data here? 2, 4, 6, 8, 10, 12, 13 data. So n will be 13. Find out the standard deviation and then divide it by square root of 13. You get the standard error of mean. Now, once the standard error of mean is obtained, plus or minus 2 times will give you confidence interval, right? And then similarly, the prediction interval is also obtained. And now see here, 8.74 is fitting in the confidence. Oh, I'm sorry. Yeah. Yeah. 8.74 is fitting in the confidence interval as well as fitting in the prediction interval, right? And this is a mathematics. You wanted to check it in real time. If you want to check it in real time, what will you do? You will actually find babies. You will actually find baby having a height of 75 centimeter, right? Let's say you are luckily able to find one baby having a height of 75 centimeter, and you immediately measure the weight of the baby. The weight of the baby will definitely will fall here. Suppose if you are lucky enough to see multiple babies, 3 or 4 babies having a height of 75 centimeter, then take the average weight. That average weight will now fall in your confidence interval, right? So this is the meaning of confidence interval and prediction interval. See here, for the same thing, the ANOVA table is created, model summary is created. Look at the R squares. Adjusted R square, predicted R square, all of them are close to each other. That means your regression is very strong. You have enough data to comment, the way you want, the way we are discussing right now. And look at the S value. S value is very, very low. S very, very low means the residual is low. When the residual is low, then when the residual is low, then adjusted R square is high, your predicted R square will be very high, right? And this is the regression equation. Now, this is for the confidence interval. Confidence interval is a range of values that is likely to contain the average value of y for a selected value of x. You understand? You have to repeat the experiment multiple times. get the Y value, calculate the average. Average will lie in your confidence interval. The confidence interval formulas I have written here. Fitted value plus the t statistics into standard error of the fit, plus or minus. See here. This is a fitted value, 8.74. See here, when I substitute, 8.74 is coming. And now confidence interval will be upper limit and lower limit. You know upper limit is 8.92, lower limit is 8.2. The gap between upper limit and lower limit, that is called confidence interval. How much is the range? 0.37.
0.37.
And
that means this will be within 0.37 we have to keep. It's like that.
You can expect your value to fall inside the confidence interval if you have done multiple experiment and you have calculated average. The average of your multiple experiments, you can expect to fall in the confidence interval. That is the use of confidence interval. Clear? If I ask you to write the exam 3 times, and now I will calculate your average mark, and now I will use your average mark, I can expect your average mark to fall inside the confidence interval. All right. Now prediction interval. Prediction interval is the range that is likely to contain a single future response for a selected value. Fitted value, once again, it is 8.74. But now it is, the, what do you call, prediction interval is 9.11, and then the lower limit is 8.36. The interval is 0.75. Earlier, the confidence interval was only 0.37, but here it is 0.7. Always prediction interval will be kept wider than the confidence interval, because the prediction interval should be able to contain the single response, right? Not multiple response. That's why it is wider. So I think this we discussed enough. All right. So see here, and final summary before we go for the break. So the problem we discussed enough. Height of the baby, weight of the baby, regression equation is available, model summary is available. Everything is is going great here. Predicted R square itself is 98%. Now when the height of the baby is 40 centimeter, what could be the weight of the baby? When the height of the baby is 40 centimeter, I don't know whether it is centimeter or millimeter, maybe millimeter, I believe, right? 40 millimeter. 40 millimeter means the baby has not yet born. Now, where is the baby? The baby is in mother's abdomen, isn't it? So, through scanning, the doctor has judged that height is 40 millimeter. Now, what could be the weight? How the doctor will weigh the baby now? Any idea?
That I think mother's weight minus something like that.
That's what. How will you do it? Will you separate the baby from mother just for the purpose of weighing? Not possible, right? So you have to use regression. A situation clearly demands regression. Now, with all your past history, you have the relationship. So when the height of the baby is 40 mm, the weight is expected to be 1.21. We all expect our baby, to be born with proper weight, isn't it?
Yes.
So all the parents will be curious of knowing the weight of the baby at the time of birth. We expect the normal baby. So the doctors, is checking well in advance so that they can treat the mother and then give some, guidance, and thereby the baby is safe and mother is also safe. Do you understand? This is how the regression is, helping. And now the standard error of the fit is calculated and 95% confidence interval. That means the doctors are confident that though they expect the baby to have a weight of 1.2, they are very much confident that the weight will be at least between 0.9 kilograms to 1.5 kilograms. Do you understand? Sir, no.
Yes.
Yes, sir. Yes, sir.
Yes, sir.
If you are a medical doctor, the baby has not born. It's still inside the mother. But now you will look at this value, isn't it? So the confidence interval, because when do we actually get the value? Only when the baby is born. Till then, you have to rely on the confidence. That is why we calculate the confidence interval. Clear? Similarly, case 2. In case the height of the baby in the scanning, through the scanning, if the height of the baby is 60 mm, what could be the weight? Oh, now the weight is good, 5.5. That means the baby just born or almost on the delivery stage. So now the confidence interval is this much. Prediction interval is here. If the height is 75, yeah, mom, what does it mean? The baby is now 6 months old, isn't it? And you can see, and you can also observe several babies having this weight when they are in the age of around 6 months, isn't it? You check the average value, that will be here. Hope it is clear to all of you. So regression is a technique. You can use it to generate an equation describing the statistical relationship between X and Y. As a Six Sigma team, you can make use of the regression to investigate any suspected relationship. And if the predicted R square is healthier, you can also use the regression for prediction purpose. Regression results indicates the direction, size, as well as statistical significance. The regression coefficient will estimate the changes in the response variable for unit increase in the corresponding predictor variable, the X variable. Regression can be used to model linear, quadratic, cubic relationship, or even higher order relationship. So this completes our discussion on correlation and regression. Now, one more thing I would like to, I'll be teaching you after the coffee break, which is very, very important, design of experiments. So I'm open to your questions.